Now, when we talk about inverse Z transform, it means we are having a function of Z, okay, and the corresponding answer should be either a constant or a function of k. So what we have done, we are having a function of k, we applied the Z transform operator and we got a function of Z, right? All the results is in terms of Z. Now we apply inverse Z transform, which we denote by Z to the power minus 1. So to convert the function of Z to the function of k, so it means we want to get to the return back to the original function. So we apply inverse Z operator on that. So it means now when we are working on Z transform, we are working from left to right for the Z transform. Now when we are working for inverse Z transform, we use the table from right to left. It means we will look for the functions here in the corresponding answer over here. Okay, so quickly what it will be, the first rule will give you inverse Z transform of Z over Z minus 1, that will be 1. Inverse Z transform of Z over Z minus 1 square gives you k. Inverse Z transform of Z over Z minus a gives you a to the power k. Inverse Z transform of az over Z minus a to the power 2 gives you k a to the power k. So all these things are similar to what we have done in the case of Laplace transform. Now here one of the important thing that you need to notice that when we are taking inverse Z transform, it is important that in all the rules Z should be there in the numerator. So you can see this thing even from the table. Z is must. Okay, so what I mean to say that, like if you come across the term like inverse Z transform of 1 over Z minus 1, you will not able to find it by using these rules. So it is must that we should have Z in the numerator. Otherwise you are not able to work with this. Okay, so this is one thing. Now let's work on some other kind of questions using the same thing. Like we worked on this thing, like inverse Z transform of Z over Z minus 1 is 1. So what will be inverse Z transform of if I have 5Z over Z minus 1? So what will happen? It will be 5. So why it became 5? Because we have rule for Z over Z minus 1 as 1. So 1 multiplied 5 gives you, say if you find, if you have to find inverse Z transform of Z over Z plus 3. So what it will be? So yes, it is minus 3 to the power k. Now suppose in addition to that, if I have say 5Z over Z plus 3. So what it will be? Okay, so it will be 5 times minus 3 to the power k. And how do we explain that? Because we have 5 which is a constant which is not required, so we keep it outside. Z over Z plus 3. So if it is plus 3, we should get minus 3. Changing the sign, if it is minus a, it become plus a. So this is how it works. Okay, so similarly we can have the question like inverse Z transform of, let's say 3Z over Z plus 3 to the power 2. So in this case, which rule we are going to use? Rule number 4, isn't it? So it is direct implication of the last rule. So let's see this. So as we know that it is using rule number 4, So if it is a, we need minus a here, and it will give you plus a. So here, if it is plus 3, it means here we need minus 3, right? So I'll say that, like, let's modify it. If it is 3z over z plus 3 square. So if it is plus here, we need here minus. So if I simply write the minus, it means I am changing the question. So I have to multiply minus and minus. So this minus sign outside, and in place of a we have this minus 3, because z plus 3 we can write z minus of minus 3. So we say that a is minus 3. So this is minus k a to the power k. Now if I just modify the question like z over z plus 3 power 2, how does the answer will change? So now in this case again we have to make use of this rule, because here we have z plus 3 to the power 2, and this is the only rule which is giving you flexibility of plus and minus sign. Okay, because here it is rigid for 1. You cannot use this rule unless you have 1 here. So to make use this rule, if it is minus a, you should have plus a here, and vice versa. So if it is plus 3, you should have minus 3 here. So to get minus 3 here, what you can do? You multiply and you divide by minus 3, right? So we can rewrite it as minus 1 over 3 inverse z transform of minus 3z over z plus 3 to the power 2. So let me erase it from here to avoid confusion that the question is same. Okay, and then just give your answer, minus 1 over 3, and this term become k a is minus 3 to the power k. So see, it's not difficult. The only thing is we are modifying our question in such a way that we are able to make use of one of these rules. That's the idea. Let's move to another kind of questions that can be asked from inverse Z transform. How you will deal with inverse Z transform of, say you have 3z over z plus 1, z minus 1. How you are going to deal with it? So remember that inverse Z transform, similar to Laplace transform, you cannot split it into two parts when it is under multiplication. You are able to split it only when it is addition or subtraction. So what I mean is, here you cannot work it like, say, some number over z plus 1 multiplied with z minus 1 and then find the rule separately for them. No, you cannot work in this way. So how you will work with these terms? So here we have to make use of partial fraction like we did in the Laplace transform. So you have to use partial fraction to convert it into some constants, divide by z plus 1 and another constant divide by z minus 1, and in between it should be plus or minus. Use the partial fraction for that. Now the partial fraction, you can use it in the same way as we have used it for Laplace transform, but here we have just one modification. Like in Laplace transform, in the case of inverse Laplace transform, whatever function we are having, like suppose if you are having, say, 3s over s plus 1 s minus 1, you are considering the entire expression to use the Laplace inverse, use the partial fraction, isn't it? But in this case, when you have 3z over z plus 1 z minus 1, you don't use this expression for partial fraction. Instead, you are going to use 3 over z plus 1 and z minus 1 to use it as a partial fraction. Now, why so? We are dividing this numerator by z, and then we are getting this term to use it as a partial fraction. Okay. See, for example, suppose you have this question 3z over z plus 6 z minus 3. Now we know that we have to use the concept of partial fraction. So suppose we consider the entire term for using the partial fraction. So how it will work? A over z plus 6 plus b over z minus 3. So as per the procedure, we write it as, we simplify it by adding the terms, right? So this gives you 3z over z plus 6 z minus 3. So when we compare the numerator, we will get a times z minus 3 plus b times z minus 6. So it's the same equation. Now it is in terms of z, unlike in terms of s in the case of inverse Laplace transform. So as we have two constants, we need two values of z. Those values we will be getting from this term. So if we put z plus 6 is equal to 0, this gives you z is equal to minus 6. Substitute it here. 3 times minus 6 gives you a times minus 6 minus 3, b times minus 6. Sorry, it is plus 6 here. Plus 6. This cancels to 0. So this gives you minus 18 is equal to minus 9a. That gives you a is equal to 2, a constant value, right? Second value we get from z minus 3 equal to 0. This gives you z is equal to 3. So when we substitute it here, this gives you 3 times 3, a times 3 minus 3, b times 3 plus 6. So this becomes 0. This gives you 9 equal 6 plus 3, 9b, giving you b is equal to 1. So we don't find anything wrong up to here. So now the problem comes when we substitute the value here. So what we get? 3z over z plus 6 z minus 3 equal to the value of a, 2 divide z plus 6, value of b, 1 divide z minus 3. Now we have to apply inverse z transform. So how do we apply the inverse z transform on these terms? So we come across the term inverse z transform of 2 over z plus 6. Inverse z transform of 1 over z minus 3. So as I said here, in all the rules, we need z in the numerator, right? We need z. So we stuck here. There is no z. No z term in the up. No z term in the numerator. So to overcome this issue, what we are going to do, we will keep the z safe from the beginning. We do the partial fraction for everything except z. We will not use this 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 z. So we get different values of a and b. Okay, so it will be say 3, and you will get here a as 3 over minus 9, that is minus 1 over 3, and we will not have this is 3, so we get the value of b as 1 over 3. So now we can write 3 over z plus 6 z minus 6 as minus 1 over 3 and plus 1 over 3. Now we need z, so we write 3z over z plus 6 z minus 3. So now we are multiplying this z. Keep z safe for end. So now we are multiplying this z here. So we get minus 1 over 3 z over z plus 6 plus 1 over 3 z over z minus 3. So now we are having rule for this. So this is how we tackle with this problem. So that is the reason we always divide the numerator by z and use it for the partial fraction. Here again, so when you have the question like z square over z plus 3z minus z plus 1, it's clear that we have to answer it by partial fraction. So when we are answering it by partial fraction, you divide the numerator by z and do the partial fraction for this term, and then after getting the values of a and b, multiply z on both sides and then apply inverse z transform to get the final answer.